with a mean of 4.8 and a standard deviation of 1.2, a standardized ant length of negative Z score, negative 0.5 corresponds to an actual ant length. Okay, I just need to find my Z score formula. Where is that? Here. Okay. So we've got the Z score formula of X minus the mean of X over S. Is this what you used? I think this is what you used.
Yeah.
And then we've got a Z score of negative 0.5 equals I think you might have got it right though. 4.8 is our mean over 1.2. So 0.5 times negative 0.5 times 1.2 equals negative 0.6. And then plus 4.8. I got 4.2. I think when you came from this step here to over here,
Yeah.
you got to put the negative there. So it should be negative 0.6.
Oh.
And then negative 0.6, and then you take the 4.8 over. So it's plus 4.8. And then so it's negative 0.6 plus 4.8 equals X. So you got all this part here right, and you took the 1.2 over, which was right. You just forgot to have negative 0.6.
Okay.
And so then it's just negative 0.6 equals X minus 4.8. And then negative 0.6 plus 4.8 equals X. So it's C, 4.2. Is that all good?
Yeah.
Cool. Have you done question 3?
No.
Okay, do you want to do it?
Sure.
Okay. So the head of a population of boys is normally distributed. Okay. So for this one, I'm going to draw up that picture with the bell curve so I can like see what we're working with. So a mean of 49.5 and a standard deviation of 1.5, so 49.
Like, I don't get it. Like, what?
Okay. So I think if you get a question like this, probably just draw it out, because I feel like if you draw it out, it like helps you. I don't know. I feel like drawing it, I always would draw it out because it would just like make so much more sense if I did that.
Okay.
So it's just going to take me a second. Because once you draw it out, you can see where like the percentages go.
Yeah.
And then you can figure out what percent would be between 48. I mean, below 48. Okay. So this is our bell curve. This is a mean. That's a standard deviation of 1, standard deviation of 2, standard deviation of 3, standard deviation of -1, -2, and -3. So does this picture here, does it make sense how I got these numbers?
No.
Okay. So we know the mean goes directly in the middle, and that's a mean of 49.5. And then this 51 which corresponds with the 1, is just one standard deviation above the mean. And if the standard deviation is 1.5, you can just do 49 plus 1 standard deviation, which is 49 plus 1.5. Does that make sense?
Yes.
And then 2 standard deviations would be 49 plus 1.5 plus 1.5 because it's 2 standard deviations above.
Yeah.
Cool. So that's how I got the picture. And then it says 400 of these boys are selected at random and measured the number of these boys with a head circumference of less than 48. So 48 is here, which is 1 standard deviation below the mean. And so they want to know how many boys are below, or like this way down. Is that cool?
Yeah.
And so we just got to figure out what percent is like between 1 standard deviation. So what percent would be in here, do you think? It says on your reference sheet, I'm pretty sure.
68%.
Mm-hmm. So if there's 68% between 1 and 1, then there must be 32 split on either side.
Yeah.
And so half of 32 would be here and half of 32 would be here. I mean,
Wait, it said 95% between -2 and 2.
yeah,
Oh, okay.
48 is between, like they want 48. And so 48's at -1. So if we figure out what's between 1 and -1, we can figure out what's on either side. And then if we can figure out what this green one is here, that will tell us like what the percentage will have a head circumference of less than 48. And so if there's 68 in the yellow, that means on either side of the green will be half of 32. Because 100 minus 68 equals 32, I'm pretty sure. Yeah. And with like normal distribution, everything's even. So that means on this side would be 16%. And on this side would be 16% also.
Okay.
And so then it says 400 of the boys. And so we want to know what 16% of 400 is. So 400 times 16% is 64. So where can I write that here? 400 times 16% equals 64. So the answer would be C. Do you want me to explain it again?
Yeah, if you don't mind.
Cool. So we're all good with how we drew the red like curve and the numbers?
Yeah, I just don't understand like why we had to draw it, if you know what I mean.
Okay. Well, you don't have to draw it. Like you could just do it in your head, but I think it's so much easier for like me to visually see it.
Yeah.
Because
Then
once I've
formula.
done this, like once I've drawn the red thing, then I can like go back and see what the question asks. So it's saying that from like here to here, the whole red thing is a total of 400 boys. And like the mean of the 400 boys had a head circumference of 49.5 centimeters.
Okay.
And they want to know how many boys had a head circumference of less than 48. And so when we when we have a look at the diagram we drew, we can like see 48 right there. And so like it's pretty easy just to like know that we're looking at between -1 standard deviations and 1 standard deviation. Because 48's at -1. And so then if we have a look on the reference sheet, we can see that between -1 and 1 is 68% of data. And so then on either side must be half of whatever's left over. And so 32% is left over. So then half of 32 would be 16 on this side and 16 on this side. And then if we add that up, it should equal 100. So 16 plus 68 plus 16 equals 100. And so 100% of the data is in between here. And we want to know what percent of data was less than 48. And so 48 down would be 16%.
Right.
Because from like here above to here was 68, and then here above to here was 16. So this would have to be 16% here. And then it wanted an actual number. And so if we know that 400 boys in total, and we know that we had 16% of 400 below, you can just put 400 times 16 into your calculator, 16%, and it should give you 64.
Right.
So that's how you use the standard deviation and you use the normal distribution. Like you might not have to draw this, but if you don't draw it, then you just have to like work it out in your head. So you could do, what would you do? You could do mean equals 49.5. And then they have a standard deviation of 1.5, and you need to get to 48. So you'd probably just do it. So 1 standard deviation below would equal 48. And like if that wasn't your number, then you'd have to keep going 2 standard deviations below until you got to like your number. And so then what would be 46.5? And then you just have to do it in your head. So you'd have to go between 1 and 1 standard deviation is 68%. And so below 1 standard deviation will be 16%. So 400 times 16% is 64. So you could just do it in your head like that. But for me, it's so much easier just to draw it and then I can see. And like if it was a long response question, and there was like multiple of these connected to like the one problem, then you could, if you drew the diagram, you could use that diagram for every question and you wouldn't have to be working out for each one, if that makes sense.
So they're all the same diagram.
Yeah, if it's with the same, if this like information was used, if it said use for question A, B, and C or whatever, then you could do it. But if you're any questions, like let me know because it's kind of confusing.
Yeah, it is really, like I don't, like, it's not that I don't get it, it's like I don't get what we're meant to be finding, if that makes sense.
Mm-hmm. So normal distribution is when, I don't like know the exact definition for it, so let me see if I can find the textbook definition for it. But it's like where the spread of the data is like, is even, when it's like symmetrical. And
yeah.
So and so that's why we can draw that curve, because it's like symmetrical. It'll have like the same up as it is down. And so it's just like, it's an easy way to figure out like where, if I got like, if the mean of a test was 50 and I got 62%, and you're like judging a whole class, it's easy to see like if that test was well or if that test was like, if your score was good or if your score was bad. Because if your score was below, like was like 2 standard deviations below the mean, then you know that you're in like the bottom 16% of your class. Whereas if you're in like 2 standard deviations above the mean, then you know you're in the top 16%. So it's just an easy way to judge data if it's like symmetrical and even data.
Yeah.
But it's just like, if you know how to do it, just don't think into it too much. Just do it. But yeah, like I don't know the purpose of it because I've never used it other than in my HSC exam, but you just have to do it. Yeah. Normal distributions where it creates the shape of a bell curve, which is like that.
Oh, so A.
Yeah, A. If it creates like that shape. If it's like symmetrical, then that's normal distribution. So then you can probably tell that it's either A or B because they're the only like symmetrical ones. And then you have to know that it makes a bell curve. And so if it makes like that shape, then that's the one. So A. Cool. Question 5. Okay. Speed limit outside of school is 40 kilometers per hour. Year 11 students measured the speed of passing vehicles over a period of time. They found the set of data to be normally distributed with a mean of 36 and a standard deviation of 2. Okay.
Are we drawing it again? I feel like that would be.
Yeah. I feel like drawing it gives you a good like understanding. So the mean goes in the middle, so the mean's 36.
Yeah.
Then we have 1 standard deviation above, 2 standard deviations above, 3 standard deviations above, -1, -2, -3. So 1 standard deviation would be 38, would it?
Yes, because it's above 2.
2. And so then 2 would be 40, then 42, and then 34, 32, and 30. Okay.
And then, so now what do we do?
So now it says what percentage of vehicles passed at a speed greater than 40. So we look to where 40 could be. So 40 is here.
Yeah.
So what percentage of data is between -2 and 2?
Doesn't it? Wait, what?
Like on your reference sheet.
Yeah, but why are we doing that?
Because if we figure out how much is in here, we can figure out how much would be on either side on yellow.
Oh, okay. So
And
95.
Yeah, so 95 would be here in red. So that means in yellow would be 5, like half of 5%. So 2.5 on this side and 2.5 on this side.
Yeah.
And then it says what percentage of vehicles pass the school at a speed greater than 40. Well, greater than 40 was only 2.5% of vehicles passed greater than 40.
Mm.
Does that make sense how we got that?
Yeah.
Cool. And so there's like, if you have a look at the answers, there's 3 like trick ones. So like people could say there's 95 between -2 and 2 and 40 is at 2. So then they pick 95. Or they could see that there's 95 and then think there's 5% on outside of 95. Does that make sense?
Yeah.
But they think that 5%'s here and 5%'s here. But if it was 5% on either side, then it would come to a total of 105. And so that's like, you can't have 105% of data.
It's always 100%.
Yeah.
Is that right? Yeah.
Yeah. And so you have to have half of whatever's left over. So 100 minus 95 is 5, and then half of 5 is 2.5.
Yeah.
Cool. Any questions with that one, or is that all good?
No, that's all good.
Cool. Let's have a look at question 6. Okay. The time in hours that each student spent sleeping on a school night was recorded. The distribution of these times. Okay, so they've like given you this information, but that information here is already on your reference sheet. So they probably won't give that to you on your test.
Okay. What does it mean it was recorded for 1550? Like, what does that mean?
So you know how in the previous question we got the answer of 2.5%?
Yeah.
Instead of leaving our answer as a percentage in question 6, they want us to figure out like what percentage of the number that they actually recorded. So they recorded a total of 1,550. And so say we get like 2.5%, they'd want us to figure out how many people that actually was. So then you'd have to do 1550 times 2.5%.
Okay.
Does that make sense? So instead of just leaving it as a percentage, they've actually given us like the information to turn it into an actual number.
Right. Okay.
Yeah. It's just like another step that you have to do at the end. So I'd probably just draw it up as well.
Okay.
Like you probably don't have to draw it up, but I just think it's so much easier for me. So mean would be 7.4. 1 standard deviation above would be 8.1, 8.8. Okay. There we go. So once it's up, or like once you've drawn it,
yeah,
it then says how many students would you expect to spend more than 8.1 hours sleeping on a school night. So we find 8.1, which is here.
Yeah.
So we want to figure out how many people spend more than 8.1. So how many more is on that way. And so then if we figure out how much is between 1 and -1, then you just have to split it on either side again.
Right.
So between 1 and -1 is 68%. So half of 68 would be, I mean, the leftover of 68 would be 32 because 100 minus 68.
Yeah.
And then half of 32 is 16. So 16% of people would
Wait, why do you have to do half of 32?
Because we know that if 68%'s here in yellow,
Oh, right.
then 32 would be spread out on either side, and because it's symmetrical and even,
Right.
then half would be on one side and half would be on the other.
Got it.
And so now we've got 16%. So now we can do 1550 times 16% to figure out how many students would spend more than 8.1 hours sleeping. Because like in the previous answer, in question 5, we just left it as our percentage, but this time they've given us that number to turn it into 248.
Is that the answer?
Yeah.
That's not an option. Oh, you said 248. Sorry, I thought you said 100.
Oh, no, 200. 238. So if you were like, I can't be bothered to draw this diagram up.
The diagram we just drew.
Yeah. Then you'd just have to like do it in your head. So you'd have to think that 7.4 plus 0.7 will give you 8.1. So 8.1 is one standard deviation above. And then you just have to think in your head between 1 and -1 is 68. So on either side would be 16. So 16 would be above 8.1. So 16 times 1,550. But I don't like doing stuff in my head. So that's why I do it like that. I just draw the picture, and then it's so much easier for me to like visualize what I'm trying to do. Cool. So is that one all good?
Yeah.
Cool.
That's a good one.
Okay. 17.
Okay, I'll try and do this one myself.
Yeah.
And then I'll probably get it wrong in it. I'll tell you.
I'll do it in my book.
Do I have to plus 75 by 11?
Yeah. To get one standard deviation above. Yeah. Okay, this one's a little bit trickier.
Okay.
But I'll go through it with you. Give it a go, and then let me know when you come across the problem or you're stuck.
Okay. Yeah, I don't get it.
Okay. Did you draw up a picture?
Yeah.
Cool. What numbers did you get?
The ones that it says.
Okay, so 75 in the middle.
Yeah.
And then
I got 86, 97, and 108.
Perfect.
And then 64, 53, and 42.
Cool. Okay. And then we came across a problem because it said 53 and it said 86, didn't it?
Yeah.
And they're like in different sections. So 53 is like between -2 and 2, and 86 between -1 and 1. We can still do the same thing. We just have to do it in 2 goes. So we know, so we'll do 86 first. So we know that between -1 and 1 is 68% of data.
Yeah.
So on either side of that would be 16%.
Okay.
Which is half of 32, because we know that 100 minus 68 equals 32. And if it's split evenly on either side, then 32 divided by 2. So above 86 is 16%. So it says greater than 86. So we know 16% is greater than 86. And then we'll do the same thing for the -2 section. So between 2 and -2 is 95% of data. And so leftover is 5%. And then half of 5% would be on either side. So below 53 would be 2.5, and above 53 would be 2.5. And so the question says, what does it say? The percentage of 18-year-olds with pulse rates less than 53, we know is 2.5. So it's 2.5, or greater than 86, we know is 16. So 2.5 plus 16 equals 18.5%. So it'd be D. Does that make sense how we did like
it does.
2 different applications of it? Cool. It gets kind of repetitive because it's always like, it's pretty much all the time like well, that's the rule, 68, 95, 99.7. So you're always doing like 68, then half of 68, half of 32. But yeah. Okay. Do you want to have a go at doing this one?
Yeah.
Okay, this one is also a harder one as well.
Oh no. What's half of 16%?
8%. 8.
Would I go 68 plus 4?
I don't know if that would work.
Because it's like, you know how it's between
Yeah. I see what you're doing, but I don't think that works.
Okay.
Because I don't know why it wouldn't work, but I think it's because it's a different thing. It's like instead of one standard deviation, it's, I don't know, but I don't think that will work. It's also not an answer. 68 plus 4 would be 72. So I don't think it works. But I think you're on the right track, but you have to use the 95 between -2 and 2 as well.
Is it 81.5?
Let me check. Yep.
So it's 13.5.
Yes.
Plus 68.
Yes. Did you get?
So why would I have to plus it by 13.5? Like, how did I get that?
Okay, I'll draw it up quickly. So this is our base. Then we have 23 here, 28, 33, 38, 18, 13, and 8. And that's -3, -2, -1, 0, 1, 2, 3. Okay. So we got the 68%. Let me do it in a different color. So 68% from here to here.
Yeah.
Then we got 95% from -2 to 2. And then from 18 to 23, which is in green. So how can I explain? So we've got the 68% is in here, yeah?
Yeah.
In the yellow part. And so if we do 95, I shouldn't do it in yellow because that's hard to see. If we do 95 minus 68, that will tell us how much is left over on the blue.
Right. Yeah, why didn't I think of that?
And so that gives us 27 is split on either side. And so we know that half of 27 will be split on either side. So 27 divided by 2 equals 13.5. And so we know 13.5 is here and 13.5 is here. And we want to know what's in green. So that's 68 plus 13.5.
Okay.
And so 68 plus 13.5 equals 81.5. So you had the right idea, but
At least I get it. Well,
yeah. I think it's because although there's 16% on this side and 16% on this side, you just don't know how much. Like, you don't know if 10%'s here and 6%'s here. Like, it's just different. But yeah, because that part is not split evenly, but the on either side it is, if that makes sense. But on each side, you don't know how much is split. Does that make sense?
Yeah.
Yeah. Okay, next question.
I'll send you a photo of my other page.
Okay, cool.
Oh, wait, I already did.
Yeah, I think I already have it. Let me stop this share. Okay. I think I have to download it because, yeah, I do. That's fine. So I can rotate it so it's on a angle. Okay. All right. Do you know positively skewed stuff?
Yes. And I'm just trying to... If it's smaller, standard deviation. I'm trying to remember which side's negative and which side's positive.
Yeah.
Okay, is it? Is it D?
Oh.
Or is it A?
I think this way is correct. I think this way is positive. And I think these two are negative. So I think those two are positive and then those two are negative.
Yeah.
But just because it says smaller standard deviation. And so standard deviation is the spread of data. And so if this is marks from 0 to 100, do we have like a smaller spread in B because they're all clumped in this range here? Do you think? Whereas D is more spread out. It's more like, do you see what I'm trying to say? I don't know.
Yeah. No, I do. I just don't know the answer.
Does this have answers?
No.
Just see. Oh, we can find this. Okay. What is it?
I'm trying to go through my book and like
2006 HSC question.
Oh, here it is. Oh wait, that's not there.
2006 HSC question. What one is it?
Well, we're both wrong. It's A or B. I mean A or C.
Oh. So positive's the other way.
Yeah. I knew there was something tricky about this.
Dun, 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 dun. I just need the answers. Where's the answers? Here. Okay, then it must be C.
Mm.
Okay. C. These two are positive. Oops.
Yeah.
Positive. And these two are negative. And then, like, does it make sense why this one has a smaller standard deviation? See?
Yeah.
Okay, cool. Because, like, the data's clumped in this space instead of being spread out, so it has, like, a smaller spread.
Yeah.
Okay, so C. Okay,